Hello everyone, welcome back to this lecture series on Introduction to Machine Learning. So this session is about Python implementation of support vector machines. This is a follow-up lecture uh, on the support vector machine theories lecture. Here we will try to implement the concept of support vector machine that we discussed in the previous lecture on using Python and Jupyter notebooks. So the plan is we will look at three different we will try to implement support vector machines on three different case studies as three different case studies on two data sets, and we will also look at a homework project for all of you. So without any further delay, let's get started. A general rule of thumb, before starting any kind of Python implementation, we need to import all the libraries that are going to be used in our program. So we start with importing pandas, numpy, and matplotlib to plot something in seaborn for some visualizations, and we make a matplotlib inline to see all the plots in the output cell just after the code cell. So now we need to start with the data. So here for this particular example, this particular implementation, we are using an inbuilt data set that comes inbuilt with the library in the library sklearn. So from sklearn.dataset, this is the module from which we are importing a breast cancer data set with the name load breast cancer. So it's a data set which comes inbuilt, which needs to be imported from the datasets module. Now I'm creating a variable cancer to hold this dataset, which creates an instance of the breast cancer dataset in our program. So to this cancer data set or data frame is in the form of a dictionary with to see the keys. I can look at I can do cancer.keys and I get data, target, frame, target name, and DESCR, mainly for description and feature names, as the main keys of this data set. So if you want to look at the description, if you just print cancer and DESCR as the key name, we get like there are 569 instances. That means 569 data points, and there are like 30 numeric predictive attributes and classes. And there are these are the information or the features that are contained in the data frame: radius, texture, parameter, smoothness, and there is a detailed description about all the features that are included in the breast cancer data set. So the classes or the target class is whether the cancer is malignant or benign, or in other words, whether the cancer is like serious or it is normal, like non-serious, right? So this is what we have to predict, whether the cancer is serious or malignant or benign, means not non-serious. So let's look at the feature names with that comes with the dataset. So I'll do cancer and pass the key name as feature names. These are all the feature names: mean radius, mean texture, mean parameter, mean smoothness, mean compactness. So all of this are the feature names, right? So let's set up our data frame. So df underscore feet is the data frame containing all the features, right? So it is I will make it as a pandas.data frame, pd.data frame, and I'm passing the data key from the cancer variable, which is a dictionary, and the column should be the feature names, right? And if you want to check the df underscore feed info, I can see, okay, there are like 569 non-null values. They are float type. These are the column names, which are like specifically the 30 features that we have that we know. And to check the target variable is 0 and 1. It's a binary classification, which corresponds to whether the cancer is malignant or benign, whether it is serious or not serious. Okay, so this target variable contains only these two classes, either 0 or 1. Now let's create a data frame for the target variable, which will include which will just include only the target variable, only this array that we saw. It looks like this, right? If you want to check the head of the target variable. Now let's look at what that feature data frame looks like. We will do df underscore feed dot head, and this is what my feature variable is looking like, right? So there are a lot of features, like lot of parameters, lot of features that require kind of a domain knowledge, right? So we need to consult the proper doctors who are experimenting, or who have the knowledge of breast cancer, right? So this all data is related to the breast cancer data set. So like we need to have domain knowledge. Case study is also taken in order to emphasize on the importance of domain knowledge, right? So since all of this data, mean radius, mean texture, mean parameter, for people who do not come from a medical background, all this cannot mean anything, right? So it is very difficult to know what is the importance of this particular feature with respect to this particular feature, right? So for this particular case study, we are not doing the data visualization part of the analysis, or we are skipping the exploratory data analysis, where we are plotting different columns or different features with respect to each other to study how one parameter is varying with respect to any other parameter, right? Because we know we need to have a proper domain knowledge. So what we do instead, we just go ahead with the build model building part, where we will build a model and we'll try to predict whether the uh, cancer is malignant or benign based on all these 30 features, right? So moving ahead to the train test split, from sklearn.model selection, we need to import train test split, which will do this, which will divide our data into these two parts, mainly x train x test and y train y test. And we are using this, the test size to be 30, and we are using this random state. So if you also want to get the same results, we should get the same, you should also use the same random state, right? Now we want to create a support vector classifier, which can be found in sklearn.svm as svc. So I have opened it for you. You can just do a quick search with svm sklearn, and this you should get, right? So it has all these parameters, c, kernel, degree, gamma, all that. I would highly recommend you guys to go through it, get a hold of all the parameters, try to read through documentation, right? So what basically it does is it will import support vector classifier in our program, and the model variable it will be an instance of the support vector classifier, which we will use in our program, right? So now I want to fit this particular support vector classifier, which is our model, to fit on our training data, right? So I want to fit this on X train and Y train. This gives me a support vector classifier. And now it's time to make predictions, right? So in the prediction variable will hold model dot predict. I want to predict whether the cancer is malignant or benign on the test data set. So I will pass X test, and I want to make predictions using my model. So prediction will hold all of my predictions, right, for the values that the my model has not seen yet. Now I want to evaluate how my model has performed. So I will import from sklearn matrices. I will import classification report and confusion matrix, right? And I will print confusion matrix here. So as you can see, like there are 13 3 plus 10 13 values or data points which were wrongly predicted, whereas 56 and 102, like 158 data points were correctly predicted. And if you see the classification report, I am performing, like the model is currently performing at 93% accuracy, which is pretty good, right? So we can stop our model search here, or we can stop our model prediction here, and we can be happy with this prediction. Or there's a really great technique which is called grid search, right? So as you see, when you go through the documentation, you will find that there are a lot of parameters on which the success of any model depends, like c, kernel, degree, and gamma, right? So there is a very high chance with that if we try to change or tune those internal parameters of the model, the performance or the accuracy of our model may increase. So like all of this needs to be done by an hit and trial method, but we can just relax and uh, be at peace, because there is a function which is already defined in the sklearn library which can do all of this for us. So basically we can just provide a range or a list of all the parameters that I want to try out. And there is a function called GridSearchCV, which can try out all the different combinations of parameters and give me the best model parameters, which are giving me the best results. So for applying this, I just need to create a dictionary. Maybe the name can be as param grid. So I want to test out, like for the C, which takes care of the uh, variance and bias trade-off, right? I want to test out this C value to be from 1.1, 10, 100, and 1000, and I want to keep test out like gamma value to be 1.1, 0.01, 0.001, 0.0001, and I want to check the kernel functions to be RBF, radial basis function, or just a linear function. So for these three parameters, I want to try out these different four choices, right? So there has to be one combination which gives me the highest accuracy or precision, right? So to find out that which combination is best for gives me the best accuracy, I will just import from SQL and model selection. I will import GridSearchCV, right? So GridSearchCV is stands for grid search cross validation. So basically it will give me, it will create a grid of all the parameters, and it will run the support vector classifier for us using all those parameters one by one. It will take up each combination one by one and will run on the whole data set, and it will give the test out the accuracy, right? So I will create a grid. I will do grid search CV. I will pass, okay, make a grid of parameters for the support vector classifier. Use the parameter grid variable, and refit is true. Like you keep refitting those values to the newer to the test database, right? And verbose is 100. So verbose is for like if you want to see some description like this, so you need to keep it to an integer value. Higher the value, you will see a higher textual description of the process. So once you do grid.fit x train and y train, you will see it will take some time, around like 10 minutes, right, depending upon your laptops or your computer's performance, right? So it will keep on running. So like it is just testing for C is 0.1, gamma is 1, and the kernel is RBF. What is the accuracy? Its score is currently 0.637. That means the accuracy is 63%. Now it will run again for a next combination, right, on a different set. It will randomize the training set. It will keep testing on all of them, and for whichever combination it gets the best accuracy, like you see the score is accuracy. So here I am getting 0.95, where C is 0.01, gamma is 0.1, kernel is linear, right? So it will keep trying for all different combinations, and it will store the best set of parameters in grid.best params. So if you run this grid dot after the above fit part of the code has been run, if you run grid.best params, you will get, okay, these are the best parameters. And if I do grid.best estimator, it will give the same thing, right? Then I can get grid predictions, right? uh, I can rerun the predictions to get the best result. So grid.predict x test y test. So basically in our case, see the when I run when we did a grid search, so our previous accuracy was 93%. See the previous accuracy was 93%, but when we after doing the grid search CV, our our performance improved to 95%, and we are able to like correctly classify 163 data points. Only 8 data points we are not able to classify. 2 plus 6 8. Previously it was 3 plus and 13, right? So there is a clear improvement of 2% in the accuracy, right? So this was the first case study that I want to discuss. Here we see a really important how to do make a support vector classifier, and how to like do the grid search CV. It's really important when you can just want to sklearn to choose the best set of parameters for you, right? It saves a lot of time. Next case study or next implementation of support vector machines using Python that we are going to see is on the data set social network ads. Let me show you the data set. Right. So in this data set, there's a user ID. We have gender, age, estimate salary, and purchase. Right. So we'll be running our data on these three columns, which are age, estimate salary, and purchase. So it is about a car. So what is the age of the person? What is the estimated salary? Whether he purchased the car or not. Right. So it is an advertisement from some car company, right? So like we'll start with importing all the required libraries. Then we import the data set. It is in form of a CSV file, which will be provided to all of you, right? X parameter will contain all the rows of second and third column only, right? And the y parameter, y variable or the dependent variable will be the target values, only the last column, whether he purchased or not, 0 or 1. Next, we need to split the data into training set and test set. So we will use train test split from sklearn.model selection, and we will divide the data using test size 25% of test size, and random state we are using at 0. So you can keep the random state at any value, or if you want to get the same results as mine, then you should also use the random state 0. Right. Then we should do feature scaling, because see all of these values here are not See, this is like the age column has range up to like maybe 100 or 50, but the salary is the range is different. So we want to do a standard scaling procedure so that all the values are between 0 and 1. So from scalar and pre-processing, we should import standard scalar, and we create an instance in as the variable s3 for standard scalar. Now xtrain should be like s3 dot fit and transform xtrain. Xtest should be s3 dot transform xtest. Now all of the values are between 0 and 1 or in the same ranges, right? So now it's time for training the svm model on the training set. So from sklearn.svm import svc, right? So I'm creating a variable called classifier, which is going to be a support vector classifier. The kernel that I am using is clearly linear. Like here I'm using linear just to show you the difference between linear and rbf. Previously we used the by default one, so it chose for by itself. We have not given any name in the previous uh, case. Here I want a linear kernel and the random state to be 0, and I'm doing classify.fit xtrain and ytrain, right? And I'm making the predictions, right? When I make the predictions, I get this much of my results, right? So 66 plus 24, that's about 80, sorry, 90. 90 times I'm making right predictions, but 10 times I'm making wrong predictions, right? So this I want just to visualize, because this code is pretty advanced. So if you want to go through it, you can go through it. It's like not actually difficult, but of course you need to do a little bit of net research, like internet research, to understand this part of code. So this is what my classifier looks like. So all these red ones, the red zone is where the based on the age and the estimated salary, the person is not buying the cars as per our model. And the green part is where the customer is buying, but it is done on the training set. So there are some errors. See all these green points which are lying in the red region, and there are red points which are lying in the green region, right? Now to visualize the test results, it's the same. This is what our test results look like, right? So this is how our model is performing on unseen data, right? Test set. So there are still some of the errors, like there are a lot of green points here, and there are some red points in the green zone. So this is why, because we have used a linear classifier, right? Remember the kernel is linear. In our case, the data here looks like it is not linearly separable, but still we are using only a linear function. That's why I'm getting this much of predictions, right? There are 10 miss wrong predictions, and there are some inter overlapping of the regions in the data set, right? But if you do like the third case study is of the same thing, same data set, but here we are using a we are using in the RBF function, right? The only difference is we are using this time as the third, like as a different case. I'm using the kernel as RBF or the radial basis function. So when I do use the radial basis function, only 7 wrong predictions are being made, right? So our result has improved. And if you see the visualization, see it looks like this, because now I'm not using any linear function, so I'm able to classify a better, right, for both training and test. So this was the like difference I wanted you guys to notice, right? So when the data is not linearly separable, using RBF function or the kernel as RBF, I am able to classify better, right? Better than linear functions. So this was what I had to discuss in support vectors machines implementation using Python, right? So I have a little exercise for you. It is going to be really interesting. It is kind of a project, right? So it is. The data set is iris flower data set. I want you guys to follow all the instructions, right? So iris data set is about it's a very popular data set, and it has data about 3 type of flowers, like based on some parameters like petal, sepal length, sepal width, petal length, petal width. You have to differentiate between what kind of flowers, what type of flower it is, right? So you need to import the data, which is like comes preloaded with the seaborn library. Then you have to perform some exploratory data analysis. Then you have to like perform the train test split, train a model using svc, right? Then you have to go for model evaluation, and you have to print like precision and result, right? And you have to also do a grid search that we saw in the very first case study, right? So thanks a lot for your time, guys. All the best, and please let me know if you have faced any issues or any doubt. Thank you.